And lastly, we're going to talk about the aerobic adaptations for the energy systems. And for longer duration training, so aerobic endurance and muscular endurance, really important factors of these is temperature regulation. So longer duration training creates more heat than other training types, and therefore the body has to adapt by becoming more effective and efficient at shunting blood to the skin to cool through sweating. So by redistribution of blood flow means that we can direct more of the waste products and the excess heat to the skin where it can evaporate into the air. And especially in sort of marathon runners would try and wear as least clothing as possible to expose more of their skin so that it's exposed to the air so more evaporation can occur, and this will then help to regulate temperature. Otherwise, if they're not releasing the temperature and sort of maintaining their homeostasis, then they're more at risk of heat exhaustion and heat stroke, and that can really sort of bring on the effects of dehydration and sort of drain the water much more quickly than the athlete wants it to be drained. So it can have really bad health defects on the performance. Another factor is the body acidity balance, and therefore the athlete becoming better at tolerating or buffering the accumulation of hydrogen ions, which increase the muscle acidity and lead quickly to fatigue. So by improving tolerance, improves the body's ability to sustain exercise above the anaerobic lactate threshold. So if we become better at removing the hydrogen ions from exercise, it means that we can sort of reduce the effects of DOMS and delayed onset muscle soreness, and therefore we can actually sort of reduce the effects of that, so we can actually get back into training quicker, so we need less recovery time. And therefore it means we can actually decrease the lactic acid accumulation in the body as well. By being able to buffer the hydrogen ions out, we can actually use the lactate and convert it into more useful stores. Another factor is the aerobic enzyme activity and production. So by having increased aerobic enzymes would help more produce ATP aerobically, and therefore by increasing the activity helps produce ATP use. So therefore we improve the capacity and endurance of the aerobic energy system. With these adaptations, the body can go harder for longer without fatigue. And this links to the idea of the graph on the left, the OBLA graph. So here we can see that the lactate OBLA sort of average is 4 millimoles, and we can see that as the workload increases, the graph starts to actually rapidly increase, and from this point where the lactate threshold is occurring, this is where the athlete is working aerobically, and then how it's shifting to using their anaerobic systems because they can no longer cope with the intensity of the exercise. If the workload is getting higher, the aerobic system can only actually work in lower intensity for a longer duration. So by increasing the intensity, you're actually starting to work anaerobic because you're producing the lactic acid and hydrogen ions, which actually is going to force you to slow down and decrease your intensity. And as we did with our investigation data, we used our lactate graphs, and we saw that from the pre-test we saw that our levels were much lower, from around 1.5 millimoles, and they went up to around 8.5 millimoles, and we saw quite a big increase in the lactate graphs. And by having a more efficient buffering system, it means we can remove the accumulated lactate from working muscle cells and convert it back to energy, so this becomes more efficient, and it helps to reduce acidosis in the muscles, allowing training at higher intensities to continue for longer. So long-term adaptations athletes will undergo is trying to delay their OBLA, to try and delay working anaerobically. So if we were to sort of draw a graph to demonstrate this they would work aerobically for longer until around further here, and then they would start to work anaerobically. We can't actually prevent working anaerobically because there's only a certain amount our bodies are trained to sort of work for, but we can actually delay the effects of it, so we can work aerobically for longer, and this will then impact our performance in sport, making us more advantageous and probably better to perform as well. And there's also supplements and things we can use in order to replenish our ATP and PC stores. But to do with our actual delaying anaerobic, it's using training, long-term adaptations to training, continuous training, that will overall improve this. And the graph on the right is just showing the idea of the different stores which we have talked about, and the RER values are respiratory exchange ratio. If we're going to be using more carbohydrates, then we're going to be performing more anaerobically, and we want to try and glycogen spare in our sports to use carbohydrates so we can use less of fats, because we can see that fats only sort of have to around 34% and then they decline quite rapidly, whereas carbohydrates, we can sustain our performance over time and they're more useful stores. So that our post-training RER might be lower, and this would indicate that the percentage of fat burning has increased. The fuel source would change to spare the glycogen in order to burn more fat. So if our glycogen stores deplete to the point where they're so low and we can't use any more, then we actually would have to convert to fats, and because they take longer to break down, therefore our performance would be compromised, because we'd have to use oxygen in order to break it down, and we'd have to sort of work at a lower intensity. And going back to the idea of delaying our anaerobic threshold, in the 20-minute continuous activities we said with the lactate, we would be able to work less, because less in terms of aerobically, but long-term adaptation and training would allow us to work aerobically for longer, so we build up less lactate, and therefore our muscles would not suffer with the increased hydrogen ions capacity, and therefore we would have a better tolerance to this and a better buffering system in order to convert them into more useful products. As you get fitter, oxygen then can be used to break down this lactate into products such as carbon dioxide and water, and this therefore prevents the lactate interfering with the blood and increasing the acidity, which we don't want to do. So a low lactate threshold can be due to certain factors of not getting enough oxygen to muscles, inefficient lactate buffering, insufficient mitochondria, and basically not being able to extract the lactate from the blood. So long-term exercise actually helps the lactic acid in the muscles so the body can deal with it better, and the skeletal muscles basically accumulate lactate with fatigue after 50 to 60 seconds of maximal effort. So if we train continuously about 90% of our maximum heart rate for around 25 minutes, we can improve our tolerance to lactic acid. If we compare this to a sedentary individual's OBLA, they will activate around 60% of their VO2 max, but a trained athlete will activate around 80% of their VO2 max. If we think about it, if you're a trained athlete, you would have a higher VO2 max than a sedentary athlete or just a performer in general. And so the increase in OBLA can be quite significant for an athlete, because their training program is much more stricter than that of a normal performer. And it causes the respiratory ratio to exceed the value of 1.0. And yeah, so we can actually delay the OBLA further. And if we link this back to the anaerobic system, by the increase in the anaerobic enzyme, particularly in the fast-twitch muscles, help to control the glucose breakdown and make it more efficient. So, and like we said, a marathon runner is really going to benefit from this by having a higher tolerance to lactic acid. It means if they start to produce it, they can actually buffer it and sort of make useful products, or more easily extracted products like carbon dioxide and water. But by delaying their OBLA, which is the main sort of factor and sort of adaptation, it's really going to benefit them so they can actually perform better in their sports. And here is just my reference list showing where I actually got my information from. Used a range of different sources, from internets to textbooks. And that is the end of Demi Burchett's 2.4 long-term adaptations to training assignment.